Good morning, students. Yes, students, good morning. Are we live? Yes, yes, we have started streaming. Yes, students, good morning. We are live. We are live. So, students, a very, very, very happy Diwali to you all. A very happy Dhanteras. आप सभी को दिवाली की बहुत बहुत शुभकामनाएं, हार्दिक बधाइयाँ from the whole of Just CA Foundation family and the whole Unacademy family also. Welcome to the family, students. You are most welcome to our Unacademy family. Hope you all are safe, healthy at your home. Please do not move out unless otherwise it is necessary. Please follow all the precautionary measures issued by Government of India and please be safe from this coronavirus. Hope, students, this Diwali brings you lots of prosperity and you clear your CA foundation exam in first go with 75 plus in each and every subject. So students, we wish you all a very good luck, a very happy Diwali and all the best for your exams. So students, before going ahead, we would like to announce that we will be starting a regular batch for May 21 attempt from 18th of November. This 18th of November, yes, today is 13th. We are starting from 18th. So only few days left. Please inform all your friends, colleagues and juniors who wish to attend this batch. This is a free batch. Yes, students, free batch. We are not going to charge anything for this batch. Almost we will covering the major topics in this batch. This is a regular batch, so each and every concept will be taught in detail. Yes, with MCQs, with practice questions, with ICI module, with additional question bank, with MTP, with past exam questions and so on. So especially mathematics, we will be practicing lots of questions on each and every topic and you will be benefited a lot, that is for sure. So we are targeting 75 plus and yes, as we move on in this batch, we will be targeting 90 plus. So as we move on, we will increase the level of training, level of participation and level of questions so that we are able to achieve our desired target of 90 plus also. So hope, students, we will see lots of students in this batch. Inform your juniors, especially because they will be attempting in May 21 attempt. So all the best, students, all the best, and yes, we will see you on 18th of November. Before going on, you know, students, what you have to do, you have to just install the Unacademy learning app. The process is very simple. Just go to the App Store or Play Store, install the application, then click on start learning. They will ask you what is your goal. Yes, students, our goal is CACS, under which you have to select CA Foundation and Intermediate. The category is CA Foundation and Intermediate. Next, click on the Get Subscription button. The window will pop up like this. You will have multiple payment options: monthly, quarterly, half yearly, yearly and 24-month package. Obviously, we will be suggesting the yearly or 2 yearly package. Why so? Because obviously if you have to cover the whole foundation and intermediate, it is not a month, 3 month or 6 month job. At least you require a year to complete the syllabus, number one. And number two, obviously it is very low cost, and in this app or in this website there is no restriction on number of views. And mind you, this course is not only for maths or for the CA foundation only. This is for the whole of foundation and whole of mathematics, and not only for our team, the the entire Unacademy team. Yes, that means all the educators listed on the app. Apart from our team also, you are able to see their lectures also. Apart from that, there are no restrictions on views. You can see any lecture any number of time as per your wish. So there are no restrictions on the number of views. Students used to ask, सर कितने views है, कब तक देख पाएंगे, कितने hours देख पाएंगे. So students, बच्चा लोग, there are no restrictions. You can see any lecture any number of times, any time as per your wish. On top of that, if you require additional 10% discount in this, the cost is 21,000 for the whole CA foundation and intermediate. But still, if you require additional 10% discount, so you can use my code, which is CA Rajgopal, so that you can avail an additional 10% discount of 10%. Additional discount of 10% in this cost. So for 24 months, the package will be only for 18,900. For 24 months, 18,900 only. So if you go on monthly, so 18,900 divided by 24, it will be just 788 rupees per month. Next step, students, just search my profile on the app, type Rajgopal Sanghi in the search bar. You will find my profile. Just click on the follow button so that you never miss my any lecture on Unacademy app also. I used to take a lot of revision classes and polls and MCQs on Unacademy app. So please click on the follow button so that you can follow me and never miss any lecture. So students, we will start with our lecture today, which is functions, set functions and relations. Yesterday we have completed sets. Set. Today we will see functions. This is the base. For your CA foundation differential calculus. Okay, so if you are able to do this functions properly, then you will be able to do differentiation, integration very easily. Okay, so we will quickly start with functions today. Yes students, what is a function? Please let me know quickly, what is a function? What do we mean by a function? Yes, quickly. Function. What is a function? Need not to answer very technically. If you don't know the technical answer, you can answer in your own understanding language. Please answer. What is a function? No. If I'm say I'm writing an equation, I'm saying that y is equals to x plus 2. Yes, simple. Y is equals to x plus 2. So when this is the value of x, these are the value of y. When x is 0, y will be 2. When x is 1, y will be 3. Like that, 2, 5, 3, 6, oh sorry, 1 plus 2, 2 plus 2, 0, 1 plus 2, 3, 2 plus 2, 4, 3 plus 2, 5, and so on. Okay, so as the value of x is changing, as the value of x will change, the value of y will also change. Why? Because y is dependent on x. Y is dependent on x. Yes, because Y is deriving its value from X. If X changes its value, Y has to change its value. So I can say Y is dependent on X. So Y is a function of X. Y is a function of X. So function of X is X plus 2. The function of X is, what is the function? X plus 2. So Y is dependent on X and X is X plus 2. The function is X plus 2. So this is what we call as function. Understood? What is function? When two variables, yes Gulnaz, two things related to each other with the rule to follow. Yes, you are partially correct. When two things are related to each other with a rule to follow, when this is a part of function, not a complete function. Yes, it is a part of a function's definition. Okay, so there should be two variables. One is dependent, other is independent. The dependent variable will derive its value from the independent variable. Okay, so the values of X, I can say that X belongs to natural number. Okay, yes, X can take any value from the natural number, and Y also belongs to natural number. Yes, but the answer of this equation will belongs to natural number, but sorry, X belongs to whole numbers. I am taking a 0, so X belongs to whole numbers. I can say X belongs to whole numbers. Y belongs to natural numbers, but the answer of this equation will always be belongs to natural number, which will be more than equal to 2. More than equals to 2. Why? Because even if we put X equal to 0, Y will be at least equal to 2. Y will be at least equal to 2. So in this case, X is called as domain. X is called as domain. The set of the independent variable, the set of the values of the independent variable is called as domain. The set of the values of dependent variable is called as codomain. And the answer for this equation, the answers for the equation are called as range. So the domain is set of whole numbers. Domain was set of whole numbers. Codomain was set of natural numbers. Okay, and the range was when we put the values of domain in the equation, we get the range. So range was natural numbers but more than equal to 2. So understood what is domain, codomain and range? It is very important. Yes, understood. Domain, codomain and range. The values defining the variable X are domain. Values defining variable Y are codomain. And when we put the values of X into our equation and process the equation, the results are range. So when we denote it with the sets, this is the set of X, this is set of Y. Okay, so when X is 0, 1, 2, 3 and so on, Y will be 2, 3, 4, 5 and so on. So what we do mapping. For 0 we have mapped 2. Yes, for 0 the value was 2. For x1 the value is 3. For x equals to 2 the value will be 4. For x equals to 3 the value will be 5. This is called as mapping. And this is one-to-one mapping. For one value of x we are mapping one value of y. One value of x, one value of y. One value of x, one value of y. This is called as one-to-one mapping. One-on-one or one-to-one mapping. Okay, understood? So this is domain, this is codomain, and the values are range. So obviously the range will always be a subset of codomain. Understood? Because the range cannot exceed codomain. Range cannot exceed codomain. Obviously the range, at least maximum it can be equal to codomain, but it should be inside the codomain. So range is a subset. Mind you, I have not written proper subset, I have written subset. So range can be equal to codomain or less than codomain. So range can be less than equal to codomain. Understood? Yes. So this was the technical base part of the functions. Okay, domain, codomain, range, and what is a function? Majority students confused themselves with functions and relations. So please remember that in function there should be a well-defined mathematical object, number 1. Number 2, there should be two variables, dependent and independent. And number 3, we will see the third condition, which is very very important, we will see while we will do the mappings, because the condition is based on the mapping and it is the most important condition, most important condition, most time. Okay, so we will move on, okay, with new topic, which is types of function. Types of functions. So types of functions, number one is into function. Into function. Yes, first we will cover functions. We will see what are the functions, type of the functions. Then we will cover relations. Okay. Yes. So first is into functions. Types of functions is first is into functions. And what do you mean by into function? The name itself suggests it is into. So there is something into, inside something else. So what is this? The range is subset, proper subset of codomain. In this case, range is proper subset of codomain. That is range is into codomain. Into codomain. Like in the previous example, what we have seen as the codomain was set of natural numbers, but the range was set of natural numbers which started from 2. So the codomain is a larger set, range is a smaller set, and range is inside the codomain. So if we draw a Venn diagram, so if this is the codomain, then this will be our range. Okay, so range is inside the codomain, range is into the codomain. That's why it is called as into function. Okay, understood? Into function based on a diagram. These types are majorly based on the diagrammatic representations. The diagram is into, the range is into codomain, hence it is into function. So next is onto function. Number 2 is onto function. Onto function. So it is simple. It is simple, very very simple. If this is the codomain, so the range will coincide with the codomain, like an eclipse. Okay, so if the blue line is range and the magenta line is, pink line is codomain. So when range equals codomain, then we call as onto function. Okay, easy. When range is equals to codomain. So for your easy understanding, I am saying y equals to x, and y is natural number, x is natural number. So the codomain will also be sorry, the range will also be the natural numbers. Okay, so range is equals to codomain. Okay, next. Next is 1-1 mapping. We have already seen 1-1 mapping. It is easy. What is 1-1 mapping? When for every value of x, there is only one value of y. For every value of x, there is only one value of y. So this is, say for 1 we have 4, for 2 we have 5, for 3 we have 6. So this is 1-to-1 mapping. Okay, so the mixture of two, 1-to-1, 1-1 into mapping, 1-1 into mapping. So it will be 1-1 into will be, there is, for one value of x, there is one value of y. Okay, So one value of x, we have one value of y, and range is subset of codomain. Range is subset of codomain. Both the conditions are satisfied simultaneously. That's why we call it as 1 into function. For one value of x, there is one value of y, and range is subset of codomain. So this is 1 into mapping. So we will see what is 1 onto mapping. Next type is 1 onto 1 onto. Yes, please. 1 onto. Obviously, for one value of x, there will be one value of y. We have one value of y, and range equals codomain. Range equals codomain. Understood? So this is 1 onto mapping. 1 onto mapping. Okay. So for one value of x, we have one value of y, and range is equals to codomain. When both the conditions are satisfied simultaneously, we call it as 1 onto mapping, or it is called as bijection mapping, also called as bijection mapping. Okay, bijection mapping. Next, many one mapping. This is simple. For multiple values of x, we have only one value of y. For example, if I am saying y is equals to x square, that is f of x equals to x square, then for value of -2, the value of y will be 4. Value of +2, the value of y will still be equal to 4. Value of -3, it will be 9. Value of +3 will still be equal to 9. So for multiple values of x, we have single value of y. So this is many one. This is many one. Multiple value of x, one value of y. This is okay. This is a function. Many one mapping is a function. But if we do the opposite, say, I can say for multiple inputs, I can have one output. Okay. So this is still a function. This is f of x. But if we have 1, 2, 3, 1, 2, and here say 5, 6, and so for one value of x, if we have multiple values of y, okay, example, for one input we have multiple outputs, then it is not a function. It is not a function. It is called as one many mapping. One many mapping is not a function. It is not a function, and it is the third criteria for any relation to become a function. This is the third criteria for any function to become a, for any relation to become a function. Okay. If it is not many one, it is not a function. If it is one many, it is a relation. It is a relation, not a function. Yes, it is a relation, not a function. It is not a f of x. It is not a function of. Okay, understood? So this was important. One many and many one. Many one is allowed. That's okay. For multiple value of x, you can have one value of y. For example, multiple input can result in single output. But for single input, if we have multiple outputs, then it is not allowed. I mean, it is not a function. It will be a relation. It will be a relation. Next is constant mapping. Constant mapping. What does this mean? For every value of x, for every value of x, we have one value of y. For every value of x, say for every value of x, we have only one value of, this is constant mapping. Constant mapping. Example, if you want example, y is equals to 0x plus 4. In this example, y is equals to 0x plus 4. So for every value of x, y will always be equal to 4. For every value of x, y will always be equal to 4. This is called as constant mapping. Constant mapping. Okay? Understood? This is the constant mapping. Now we will see another important part which we call as inverse functions. Yes. Inverse functions. We denote it by f inverse of x. If f of x is a function, then its inverse is f inverse of x, f power minus 1, kind of f power minus 1 and x. This is a notation for writing f inverse of x. This does not mean 1 upon f of x. Please do not write it as 1 upon f of x. This is wrong. This is the inverse of a function. Inverse of a function, okay? Okay? Not invertendo. It is the inverse of a function, okay? So f inverse of x is not equal to 1 upon f of x. Is not equal to 1 upon f of x. Okay? So if a very simple example for calculating f inverse of x, if y is equals to 3x, that is f of x equals to 3x. And if you need to calculate f inverse of x, so what we will do, we will start with, write y equal to 3x. At this time y is dependent, x is independent. Now we will do, this is y in terms of x, this is y in terms of x. Now we will calculate x in terms of y, calculate x in terms of y. So this will be simple, y by 3 equals to x, simple, y by 3 equals to x. So now x is dependent on y, now x in terms of y. So what we will do for calculating f inverse of x, for calculating f inverse of x, just simply replace x with y, y with x. So in this question, we have only one y, so this will be x by 3. Sorry, extremely sorry. The weather is changing. Yes. Easy. We will see another example. Y is equals to x plus 2. This is f of x, and we need to calculate f inverse of x. So simply it will be y minus 2 equals to x. Now replace x with y. So f of x will be equal to x minus 2. Sorry. F of x equals to x minus 2. Easy? Understood? Yes? Hope now you will be able to calculate the inverse functions very easily. Inverse functions very easily. We will have one more example for inverse function just for practice. It is a very easy question. Y is equals to x square plus 5. Y is equals to x square plus 5. So for f inverse, what we will do? We will calculate x in terms of y. So y minus 5 is equals to x square. So y minus 5, under root of y minus 5 is equals to x. Now we will replace y with x. So f of x equals to under root of x minus 5. Easy? Very easy. So this is f inverse, sorry. This is f inverse of x. This is f inverse of x. Very easy. Very easy. Now we will see what is composite functions. Composite functions. We are combining, merging of two or more functions. Two or more functions. Say if f of x is equals to x plus 2, and we have to denote another function. So if once we have used f of x, so just for simplification, that we can identify that there are two different functions, we use say g of x. Okay, this is simply means function of x, but for the notation purpose, because we are using simultaneously two functions, so for one function we use f of x, so for other function we use g of x. So g of x equals to say x square minus 3. G of x is x square minus 3, and now they are asking for combining f of x and g of x. So what they write is f of g of x, f of g of x, fog of x. Students used to call it as fog of x. Okay, so f of g of x. So what we'll do in f of g of x? Simply they have asked f of g of x, so you have to combine, you have to insert function g into function f. You have to insert the whole function g into function f. So the process is simple. In function f, wherever you find x, simply replace it by whole g of x. So in this question only there is one x, so we'll simply put, instead of x we are writing x square minus 3, and we will, the rest of the function will be same as it is, it will be simply 2. So the answer will be x square minus 3 plus 2, so this will be x square minus 1. Understood? This is composite functions or f of g of x. The other way around, if they have asked g of f of x, what we will do? We will insert the whole function f into function g. So in function g there is only one x, so we'll put x plus 2 whole square. Instead of x we have to substitute the whole function f, so it will be x plus 2 whole square minus 3, so it will be x square plus 2x plus 4 minus 3. So the answer would be x square plus 2x plus 1. X square plus 2x plus 1. So obviously don't get confused, f of g of x is not equal to g of f of x. F of g of x is not equals to g of f of x. In majority cases, in some cases it might be possible that f of g of x is equals to g of f of x, but in majority cases they are not equal, they are not same. Okay, now we will see one question just to check whether you have understood the concept or not. Okay, yes, can we go ahead? Done with writing? Yes. Okay. Okay. F of x is equals to 1 upon 1 minus x, and g of x is equals to x minus 1 upon x. You have to find g of f of x. G of f of x. Cough, not fog. G of f of x. Quickly find g of f of x. G of f of x. What we'll do? We will replace the whole function f in every value of x in function g. So it will become 1 upon 1 minus x minus 1 whole divided by 1 upon 1 minus x. Take LCM. So it will become, numerator will become 1 minus 1 plus x upon 1 minus x whole divided by 1 upon 1 minus x. So this 1 minus x cancelled, 1 cancelled. We are remaining with x. X only. Okay, understood? So this is the composite function. Understood? Yes. Okay, next. Even and odd function. Yes, anyone quickly, can you tell me what is even function and what is odd function? Yes, please, quickly. Yes, students. What is even and what is an odd function? Even functions and odd functions. Sorry. Even and odd functions. If f of x is equals to minus f of x, f of x is equals to f of minus x, then it is an even function. Then it is an even function. For example, if f of x is equals to x square plus 2, and if we replace x with minus x, so it will become minus x square plus 2, and still it will be equal to x square plus 2. So f of minus x and f of x are same, then it is an even function. Otherwise it is an odd. Say if f of x is equals to x cube plus 3. Okay, so in this case f of minus x will become minus x cube plus 3. So f of x is not equal to f of minus x, then it's an odd function. Okay, then it's an odd function. Understood? Yes, easy. So if f of x is not equal to f of minus x, then it is an odd function. Okay, yes. Now we'll see one technical question on function. Let us see your knowledge about logarithm and functions. The range of the function, f of x is equals to log of 1 plus x to the base 10 for the domain of real values of x when 0 less than equals to x less than equals to 9. The range of function f of x is equals to log of 1 plus x to the base 10 for the domain of real values of x when 0 less than equal to x less than equal to 9. Yes, quickly. Options, okay. Please write down the options. 0 minus 1. Sorry. 0 minus 1. Next, 0, 1 and 2. C is 0, 1 and D is NOC, none of these. Yes, quickly answer. You know range, you know domain, you know codomain. Yes, we have just seen that what is range, domain and codomain. So what they are saying that the real values of domain are 0 to 9. Yes, the domain is between 0 and 9, both inclusive. 0 and 9 both inclusive. So simply when we put x equal to 0, so 1 plus 0 is log of 1 plus 0 to the base 10 will be equal to log 1 to the base 10, which is equals to log 1 is always 0. Okay, and when we put x equals to 9, this is at f of x at x equals to 0. Now we'll take f of x at x equals to 9. So this will become log of 1 plus 9 to the base 10. So this will be log of 10 to the base 10, which is equals to 1. So the range is between 0 to 1. Easy. The range is between 0, because when we have used the least value, we have got the answer as 0. When we use the highest value, the answer is 1. So the range is between 0 to, sorry, no, minus 1. 0 to 1, C option. 0 to 1, option C. Yes, option C. 0 to 1. Option C is the right answer, correct answer. Very good. Very good. Next. If f of x is equals to 1 upon 1 minus x, find f of minus 1. Find f of minus 1. Please note that this is not f inverse of x. F inverse of x is this. Okay, this is f of minus 1. And also f inverse of x does that like this. Okay, this is different. This is inverse function, and this is inverse of x only. So if it is f of x inverse, then it will be, if the equation is like this, the f of x inverse will become like this only. Okay, this is f of x inverse and not f inverse of x. This is equal to this and not this. Okay, so please, these are three different kind of notation. F of minus 1 is different, f inverse of x is different, f of x inverse is different. Okay, so please be cautious when you are choosing the terms. This is f inverse of f of minus 1, so simply put minus 1 instead of x. So 1 upon 1 minus minus 1, so this will be 1 upon 1 plus 1, so it will be 1 by 2 only. Okay, easy. 1 by 2. Yes, understood? Very easy. Yes, it is very easy. Okay, next question. I guess there's some lag in the streaming, but yes, it is just 1 or 2 seconds. Let a function, it is written as function from R to R. That means the function, it is a function where this is domain, this is codomain. So R to R means real numbers to real numbers. Okay, R to R means real numbers to real numbers. The function is R to R, that means domain is real number, codomain is real number. A function f from R to R given by f of x is equals to x square plus 1. Now find f inverse of minus 5. Okay, please quickly find f inverse of minus 5. You don't need options for this. Okay, directly you have to calculate f inverse and then minus 5. Okay, so please quickly calculate f inverse of minus 5. Options are minus 5, null set I, that is 2 or 3, and D and no T, none of these. So first we will calculate f inverse of x. So it will equals to x square plus 1. So it will become y minus 1 is equals to x square. So it will be under root of y minus 1 is equals to x. Now we will replace y with x. So f inverse of x will become x minus 1. Yes, for instead of y we are writing just x. Now we will put minus 5. Now we will put minus 5 under root of minus 5 minus 1. So this will become under root of minus 6. Okay, it is under root of minus 6, and the negative root functions are are imaginary numbers, imaginary numbers, so they are not real numbers. So the f inverse of minus 5 is a pi set. Why? Because our domain and codomain is set of real numbers. The range is out of the codomain, which is not possible. Hence, it is a pi set. It is a pi set. We cannot define f inverse of minus 5 with this domain and codomain. Okay? So this is a pi set because this is an imaginary number and the set of codomain was real numbers. So this cannot be the part of the codomain. Hence, the f inverse of minus 5 for this value R to R is a phi set. Is a phi set. Understood? Yes? Okay. So we will have next question. Next question. The domains for which the functions f of x is equals to twice x square minus 1 and g of x is equals to 1 minus 3x are equal. Okay, so the domains, okay, there is a lag, lots of lag. I guess yes, we are live again. Yes, we are live again. So 1 minus 3x are equal. So options are option A minus 2 1 by 2, B 1 by 2 and 2, C minus 1 minus 2 and minus 1 by 2, and D NOT. No lag is very good. Yes. Okay, so they have asked that for what values of domain these two are equal. So just equate them and check what are the values. So we'll equate 2x square minus 1 with 1 minus 3x. Yes, 1 minus 3x. Yes, correct. So it will become 2x square plus 3x minus 2 equals to 0. Correct? Yes. 2x square minus 3x minus 1 minus 1 is minus 2 equal to 0. So this is a quadratic equation. Minus 4 roots of minus 4 sum plus 3 plus 4 minus 1 plus 4 minus 1. Correct? So twice x common, x plus 2 minus 1 common, x plus 2 equals to 0. So x plus 2 equals to 0, or twice x minus 1 equals to 0. So x equals to minus 2, or x is equals to 1 by 2. Yes, A is the right answer. Correct. Yes, Gulnaz, very good. A is the correct answer. X equals to minus 2 and 1 by 2. For these values of codomain, these two functions are equal, same. Easy? Yes, very easy. Next question. If a function g from R to R, a function g from R to R is given by g of x is equals to twice x minus 3, then find g of g. G of g. Here we have to calculate g of g. Put function g in function g. We have to merge function g with function g. So what we will do, wherever we have x in function g, we will put function g only. So it will become 2 into twice x minus 3 minus 3. Easy. What we have done is just simply replace the value of x with function g. Okay. When we find f of g of x, what we do? We put value g in function f. Now we have put value of function g in function g only. So this will become 4x minus 6 minus 3. So it will be 4x minus. Easy? Understood? Yes? Students, please, understood or not? Yes? Yes or no? So students, we will stop our lecture here today. Yes, Gulnaz, you're right, correct. Your answer is right. Yes, Omkar, hello beta. But we are about to complete our session. We will stop our session here. Okay. So if you have not yet liked the video, please hit the like button and subscribe to our channel if you have not yet subscribed it. Also, if you want to subscribe the Unacademy learning app, then use my code, which is CA Rajgopal, to avail additional 10% discount. And students, once again, a very, very, very happy Diwali to one and all. A very happy Diwali from whole Unacademy family to you all and your family members, your friends, your loved ones. Yes, please celebrate this Diwali with maintaining the distancing. Yes, please maintain social distancing. Please maintain the social distancing. Please be safe. Please be at home. Just, I won't say don't meet. If you are meeting with anyone for Diwali wishes, for wishing Diwali, having some snacks, please maintain social distancing. Yes. Yes, happy Diwali Omkar, happy Diwali. So everyone, happy Diwali. Please enjoy this festival with all the precautionary measures, and please be safe at your home. Please take care of your parents and your grandparents so that you will be able to give your exams easily, with ease, with no tension. Yes. So all the best students. Have a great Diwali. Have a great Diwali. Enjoy this festival and be at home. Be safe once again. Okay. All the best. All the best. Thank you. Thanks a lot. Thank you for this lovely session, students. Thank you.